quadratics to a t. You interested in tackling it?
Sure.
Okay. Let's start with the second row first.
All right.
So this is the equation in intercept format. In other words, where 1 and -3 are the x-intercepts of that parabola. Now, how would you get the vertex format and the standard format? And I will tell you the standard format is the easier one to get.
Yep. So what you can do is you can multiply the x minus 1 and x plus 3, and then multiply whatever you get by 2, and then you can complete the square. Then that gets you standard form.
Hold on a minute. I think you're right on. That's plus 2x minus 3. Multiply it out. And you're right. That is standard form.
E minus 6.
Excuse me. Thank you. And then vertex form. How do I get vertex form?
Complete the square. So factor out a 2.
What do I do with that 6?
You have it on the outside.
Okay. Now what?
Divide b by 2 and square it, so you would add 1 in the middle of the equation.
How do I balance that?
Subtract 1 on the outside.
Nope.
I'll add 1 on the outside. So.
No. When I wrote 1 in there, how many did I add to the right side of the equation?
Oh, 2, because you have to multiply by 2. Yep, sorry, I forgot that.
Exactly. That's a very common mistake. So I've added 2, so how do I balance it?
So
I'm on the same side of the equation. And the secret here is always to never change from the previous equation. In other words, here's what I want you to always be thinking on these. Before I added that 1, this vertex format that I've written is identical to the standard format. It's just manipulated a little bit.
Mm-hmm.
So when I add 1, I've added 2 to the right side. So I got to subtract 2 from the same side.
Okay.
And now this vertex format is identical to the standard format. Only it can now be written in vertex format, which is what? What goes inside?
And x minus 1 squared.
X plus 1.
X plus 1.
So
yeah.
It's always going to be the sign of the middle term.
Yep.
Whatever the sign on the middle term is, that's what goes there.
All right.
And now we have everything we need. We know A, we know the vertex, we have it in perfect vertex format. Okay, let's do one more. Let's do 3. And here they're giving it to us in vertex format. So let's see if we can solve for the other 2. Once again, the easiest one is standard format.
Just multiply out the...
So that's x squared plus 2x plus 1 minus 4. So that's x squared plus 2x minus 3. Now, this one's a little trickier, getting it into intercept format.
Just factor it out. So y equals...
Oh, you're right. I didn't realize it factored perfectly.
Minus 1 times x plus 3.
So what's A?
A is 2. A is 1.
Okay. And notice that the A is the same A regardless of which format it's in, which is
Mm-hmm.
something I didn't really realize until I got this set of exercises here, is that A is the same. Whatever A you come up in vertex format, it's going to be the same A in intercept format and the same A in standard format. Well, we can tell in vertex format that A is 1, same in standard format, same in intercept format. All right, let's look at number 1, where is all we get is a graph, and we want to come up with the 3 formats. So let me show you that graph. So let's start with the first format, intercept format. Let's write everything that we immediately can see from the graph.
The two intercepts are 1 and -1, so x plus 1 and x minus 1.
Okay. Now how do you solve for A?
Set x equal to a point on the...
Good. Pick a point.
So 2, 3.
Well, oddly enough, that's exactly what I did the first time I did this problem. And you can tell that it doesn't quite, oh yes it does, seem to go exactly 2, 3. Okay. So what am I going to put here?
So you're going to set it as 3 equals a times 2 plus 1 times 2 minus 1.
So A equals 1.
Yep.
Okay. So you solved for that, and we already know you know how to get from intercept to standard, and that's usually how you have to do, is you have to go from intercept to standard and then vertex. In other words, I'm not quite sure how to get vertex directly from intercept. But I certainly know how to get vertex from standard by completing the square. All right, you're really good on these. Let me give you a harder one. Complete the square on that.
Oh, that's a ugly number.
That's what I said. It's a harder one.
Yeah. All right. So you gotta factor out a 3.
Okay. Leaving
X squared plus...
when you factor a number out, is all you're doing is dividing each term by that number.
So 5 over 3x.
Exactly. And we put the 7 out here. What do we add in the inside? And it's always added, notice. We're never subtracting that.
Yeah, it's half of 5/3.
Which is what?
I have no clue. I don't have my graphing calculator here.
You don't need it. It's 5/6.
Oh,
Half
okay.
times 5/3.
5/6.
You just divide the denominator by 2. Or, excuse me, you multiply the denominator by 2.
Yeah.
Okay. So half of that is 5/6. So square it. What do we get?
25/30.
25/36.
36.
And how do I balance that?
You have to add, you subtract 3 by 25/36.
Okay, so that's 75/36. So all I did is multiply the 3 times the 25.
Mm-hmm.
Okay, now we're getting close to vertex format. What goes in here?
X plus 5/6 squared.
And then combining those two numbers, Let's see, that is 2 1/12. In other words, 36 goes into 75 twice with a 3 remainder. So if I want to write this as 2 1/12, makes it a little easier because now it's minus 9 1/12.
All right.
And there it is. And I doubt that you'll ever come across one harder than that. So yeah, you're terrific on this stuff. You are. You should have done really well on your quadratics test.
I feel like I did very well.
I would imagine. And there, you probably didn't get any completing the squares where there was a coefficient in front of the x squared term. That's the only one that's likely to trip you up, is because when you balance it out, you have to make sure that whatever you wrote inside there, you're multiplying by that thing you factored out.
Yeah.
Okay. All right. There's no point in going through the rest of that. You're too good at it. Let me just see if I can figure out what you're likely to start next. Are you completely done with the quadratics chapter? I think you probably are.
I believe so, because that was the complete chapter test. So.
Right. All right. Properties of exponents. I think you know these. What's that equal to? That's a multiplication.
X to the 5th.
What's this equal to?
X to the 6th.
And what is this equal to?
X to the 6th.
Mm-hmm. Okay. Adding, subtracting, and multiplying polynomials, that's pretty straightforward. In other words, if I'm adding x cubed plus 1 to x squared minus x plus 3, how do I add those together? This is the chapter I believe is coming up for you. It's chapter 6 in my book, but it's polynomials.
Just combining like terms.
What's that?
Just combining like terms.
Exactly.
So you have...
There's only one x cubed term, there's only one x squared term, there's only one x term, but there's two numbers. But that's exactly what it is. It's combining like terms. Now, let me introduce you to the hardest part of this chapter coming up. And that is when we have cubic functions. In other words, this chapter talks about polynomials that are greater than quadratics. They're higher degree. Okay? Well, if we have something like this, how do we factor that? We don't.
Yeah,
In other words, the first thing I would look for is a greatest common factor. And if you can take a greatest common factor, always do it as your first step. Second thing I would look for is, can I solve this by grouping? And I think you know grouping, do you not?
Went over it, but I've mostly just been factoring just the way we've been doing it. I didn't really understand it.
Well, here's a situation where you can group it. Okay? What you need to be able to solve a cubic by grouping is the ratio of the x cubed term to the x squared term has to be the same as the ratio of the x term to the constant. Well, this is minus 1/2. That's minus 1/2. So it's the same ratio. And what that means is that I can group it. In other words, I can put parentheses around that, and I can put parentheses around that. Now take a greatest common factor out of the term on the left, the two terms on the left.
X squared.
Leaving?
X minus 2.
Plus X
Plus.
2. Now what can you do with this? This is where it gets a little sketchy in that you probably have not ever done this before. How do you handle that situation right there?
Wouldn't that just be x squared times x minus 2 squared?
No?
Square root it?
Take a factor. What's the common factor? Is there a greatest common factor in this expression?
X.
X minus 2.
Oh.
Okay, remember that the only thing you need to factor something out is that it divide into both terms evenly. Well, I can divide that by x minus 2 and I get x squared. I can divide that by x minus 2 and I get 1. Okay, so what's left over is x squared plus 1. And
Okay.
now that happens to be an irreducible quadratic, so I could factor that further down using the quadratic formula, but I would get imaginary solutions. Okay, but this is the key, is factoring out a binomial term. Okay, and let me change this just slightly. Let's go back to the beginning and make that a minus. And make that a plus. Okay? Now, this actually makes it a lot trickier. If I start with this, well, I still have that ratio of minus 1/2, so I can still use grouping. But the thing is, I can put parentheses around that like that, but if I put parentheses around that, I've just changed it. Notice that negative sign has to be distributed to both terms, so that turns into minus x minus 2. In other words, here, let me be a little clearer. This is x cubed minus 2x squared. This is minus x plus 2. If I just go in and put parentheses around both terms, like that, this number 2 is not the same as number 1. Notice that if I now remove the parentheses, I get a minus 2. So when I put parentheses around the second term, I got to change that to a minus. Now it's the same. Now number 2 is identical to number 1. You with me? This is a tough step. You got to always remember to do it. And it's difficult because you're not used to adding parentheses and then changing terms. Okay, now watch what happens. I factor out an x and I left with x minus 2. You know what? Yeah, no, that's fine. Minus x minus 2. No, this is what I wanted. And now when I factor out the x minus 2, I'm left with x squared minus 1. Well, now I can factor that further. How do I factor it now?
X minus 1, x plus 1.
Yeah, so you end up with the 3 linear factors, x minus 1, x plus 1. And those are your 3 solutions to that cubic. Okay? Now, when you can factor a cubic using grouping, it's wonderful because that's the easiest way you will ever factor it. If I make that number, say, a 5, like that. Now clearly it's not going to lend itself to grouping, and I'm not going to be able to make grouping work. Only way grouping ever works is if those ratios are exactly the same. So how do we factor something like this? Well, there's something called the rational factor theorem, and you're going to get that in this chapter 6. And here's what the rational factor theorem says. First of all, we would expect 3 solutions to this, right? It's a cubic. The rational factor theorem says that if there is a rational 0, not square root of 2 or square root of 3 or anything like that, but if there's a rational 0, like a whole number or even a fraction like 3/2, then its numerator, p, will be a factor of the constant. And its denominator, q, will be a factor of coefficients of x cubed. Let's make this even a little harder there and put a 3 there. Okay? So, how would I begin to factor that cubic? I won't take you past 4 here. We still got 3 minutes, and this will be very helpful to you if you get a little bit of a primer on it in advance, because it's very confusing first time you run across it. In other words, my possible p's are plus or minus 1, plus or minus 5. That's the only factors of 5. They're always plus or minuses. My possible q's are plus or minus 1 and plus or minus 3. Okay? Which means my possible solutions are 1 plus or minus 1, plus or minus 1/3, plus or minus 5, and finally plus or minus 5/3. So, what the theorem says is that if there is a rational solution, and there usually is, it's hard not to have a rational solution to a cubic, because irrational solutions come in pairs and imaginary solutions come in pairs. So if it's nothing but, it can't be nothing but imaginary solutions, because there would be 3 of them, and that means they can't come in pairs. The same with irrational solutions. So one of these figures to be a solution. How do you figure out which one? By trial and error. There's 8 possible numbers there. What you do is you plug them in one at a time, and whenever that thing equals 0, you have a solution. And that's the other part of the theorem, is that if you have a linear factor of a higher degree polynomial and you divide the polynomial by the linear factor, the remainder has to be 0. If it is anything other than 0, then that thing is not a linear factor of that polynomial. All right. That's a good primer for you if that is what you're doing next. Just remember this p over q. P is a factor of this constant, 5, and q is a factor of this 3 here. And then just try them all until you find a solution. You can imagine how hard this problem would be if I said this was 12, or even worse, 24, and let's make this 6. Now you can see the number of possible factors of 24, there's like 8 of them. And the number of factors of 6, there's like 4 of them. And so the combinations get to be huge. And you're never going to get a problem like this on the test, because believe it or not, that's a 20 or 30 minute problem. there is no cubic formula like there is a quadratic formula. So when you get cubics, finding the zeros is extremely difficult. 5 times more difficult than finding the zeros on a quadratic. But you only have to find one of them, and then once you divide that polynomial by that one zero, you're left with a quadratic, and then you can use the quadratic formula if need be for the other 2 zeros. So they're not impossible. The trick is to find one zero and then go from there. And you end up using synthetic division, so synthetic division will be a part of this chapter. Have you ever learned that before?
No.
Okay, you will. I should have worked on that. But that's pretty easy, actually. You won't have any problem with synthetic division. But this P over Q concept is a tough concept. Just remember what I circled right there. Cole,
Right.
I'll talk to you next Monday.
Talk to you next Monday.
Okay.